morning everyone. Today's topic we are going to see about design of control unit. So before that we have to recall the previous classes. So the recap given by Harish.
So as I said, I am here to recap the previous class, and the main thing that we cover is various components in computer. The main components are ALU, control unit and memory. Most of them know ALU. ALU stands for arithmetic logic units. We give information to computers, instructions that are only understandable. We are living in the human language, but computers don't understand the human language. It only understands ones and zeros, that is binary. So the instructions that are given in human language that are converted into binary codes, and that is processed in arithmetic logic units. And control units is directs where the process of the code goes. And the memory is basically to store, and there are two types of memory: RAM and ROM, read only and read and accessible memory. And next, instruction execution. In instruction execution, we mainly follow four different paths, four different things.
You can go. So we are going to design a control unit. So for control unit is responsible for generating control signals. So the control signals will be like ones and zeros. So there are two methods we can follow to generate the control signal. The control signal is responsible for when and what operations to the computer. Okay. So there are two methods for generating the control signal: is hardwired and microprogrammed. Here we are using hardware components to generate the control signal. Here we are writing a program to generate the control signals. So in the first step, hardwired control unit consists of various blocks. So here the first block will be your instruction register. Here all the instructions will be stored in the computer, that is like add, subtract, multiply, subdivisions, etc. So then the instruction register will contain all the instructions. Next, the instruction decoder. The instruction decoder will fetch the opcode bits from the what the instructions will be given by the instruction register. For example, add A comma B is the instruction given by instruction register, but this decoder will decode this add A comma B into 10101011. So like that, whatever the instruction having, it will be converted into ones and zeros. Then next box will be your control signal generator. This control signal generator will have different wires from 1 to n number of wires. So for example, adding the instruction, the first four wires will be used, 1010. Similarly, this control signal will depend upon other various inputs from different blocks. Another block will be step counter. So every time the computer will do these four steps: fetch, decode, execute and instructions. The timing will be decided by the clock signal. So the clock signal will synchronize all the operations to be executed by the step counter. Okay, the step counter is responsible for doing the fetch, decode, execute and store. But the timing will be decided by the clock signal. But every time the instruction is executed, it takes different times. The fetch will take the different time, the decode will take different time. So in order to enable that, we are using this enable step counter to decide what time the decode will be done, what time the execute will be done. Then another external input, if any needed, from the example interrupt, you can call this as an interrupt. So when mobile phone is running a video, at the same time you can get a call. That is called interrupt signal, right? So the interrupt also, if you want to add, you can add through this block. Okay. Another one is condition codes. If you want to add any extra conditions to this control signal generator, that also can possible to this block. Conditions like greater than, less than or equal to. So finally, this step counter will do the fetching process at the time of T1. Then at the time of T2, it will do the decode process. Execute will be done at the time of T3. Likewise, the codes from the control signal generator will be generated using these different blocks like 10101010. So this is the binary code which will be sent to the computer. The computer knows what is the actual meaning of this code. This is a computer level language. So I as a human being, you know, the add means addition, but the computer doesn't know this add. Instead of that, you have to send 1010. 1010 means the computer will decide that addition process, but we don't know that. we don't know only this addition language. So this is your human language, this is your machine language. So our motive is to generate the control signal using your machine language process. Okay, ma'am? Thank you.
So hello everyone. So I'm gonna recap our last session. So last class we saw about various components in computer. So these various components include arithmetic logical unit, control unit, and memory. And the basic instruction sets of execution include fetch, which is denoted by F, and then decode D, and execute E, and the storing operation S. So this data flow is controlled by the data path, where it is the collection of all hardware components like CPU, monitor, ALU, and etc. So the design of control unit. Control unit is the central part where the instruction and the code is executed. So the control unit generates control signals. This control signal is generated by the use of clock signal, and then the control signal will tell what and when operations need to be done. So in order to generate control signal, there are two methods. Either it can be hardware, that is direct flow of instruction through a hardware component, or can be a microprogrammed control unit. And this diagram shows how a control signal gets input from the instruction decoder and other peripherals like instruction register, external input, and condition codes. And based on the clock signal we give, it provides the execution outputs.